Okay, so if you look at the learning outcome at here, so you're going to notice that today we're going to discuss the week 2 title, which is the carbohydrate. So carbohydrate, under the tutorial, we have two main subtopics, which is one, discuss the formation and the breakdown of maltose. Second, we're going to compare the structures function for starch, glycogen, and cellulose. But before this, let us look at the structures of monosaccharide. Even though monosaccharide is part of the lecture, but I'm not sure whether you have actually go through about the structures of the glucose in the linear form and also in the ring form. So any kind of monosaccharide, they will always appear in two different forms. One is the linear form if they have 4 carbon and above, and they can actually form the ring form when they dissolved in water. So you have to know how to draw the ring form glucose because the question can actually just giving you the molecule and then asking you to name the molecule. So the fructose, and then we also have the galactose. So this is the 3 main monosaccharides. So today we're going to go through a little bit technique in how to draw the glucose first. So this will be the learning outcome that we need to go through at the video number 1. So when you have a clear space, remember galactose and glucose both have a hexagon shape. So when you want to draw a ring shape, so the first thing that you need to draw is a hexagon. Okay, a hexagon shape. Second, draw the oxygen end. Okay, so after you have drawn the hexagon, after you have drawn the oxygen end, the step number 3, adding the line to each one of the carbon in the ring. So you can see that I use different color here. You can see that we have the carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. However, all of us know glucose is a hexose, meaning that they will have 6 carbon. So where is the carbon number 6? So the carbon number 6 is actually found outside the ring, which is at here. So this is the carbon number 6. So we add in the CH2OH here. Okay, so CH2OH, this is the final, the carbon number 6. Okay, so now step number 4, we already add in the carbon number 6. Then step number 5, we're going to add in the OH group, the hydroxyl group, and also the hydrogen atom to each one of this carbon number 1 until carbon number 5. So how to add it in? Okay, the easiest thing is we look at the carbon 5, the above part, the top part, we already have the hydroxyl group. So therefore, the bottom part of the hydrogens at the carbon number 5 will be an hydrogen. So opposite to the hydrogen is here. This end, we're going to have the OH because they are opposite to each other. And below the OH, we always have the hydrogen atom. So opposite to the hydrogen atom, always the hydroxyl, and this one will be the hydrogen. Okay, hydrogen atom, opposite is hydroxyl, and then above hydroxyl will be the hydrogen atom. So now you already complete carbon 2, carbon 3, carbon 4, and carbon 5. So step number 6, you have to add in the hydroxyl and the hydrogen atom at carbon 1. This is where the glucose become alpha glucose or beta glucose. Okay, there is 2 ring form of the glucose molecule. Even though their linear shape is exactly the same, but the arrangement of the hydroxyl group at the carbon 1 will determine whether they are alpha glucose or they are beta glucose. So when you write the word alpha, glucose, notice or not, the way that we draw is going down first. So going down first. Okay, meaning that alpha glucose, the OH is located below. Then the H is at the top. So this will be a alpha glucose. And when you draw the word beta glucose, when you write the word beta glucose, you're going to notice that the way of writing is going up. Going up. So the OH will be sitting at the top. Will be sitting at the top. So this is how to draw the beta glucose. And this is the molecule of glucose. If a question giving you the glucose molecule, then you're supposed to be able to name it correctly. But if today the question gives you a beta glucose, this is the correct answer, and they're asking you to draw a galactose. Okay, a galactose. So how are you going to draw a galactose? This one is just very simple. In order to change a glucose, a beta glucose into a beta galactose, the easiest way is changing the carbon number 4. We delete this one. Okay, these two we delete. And we're going to reverse the sitting area for the hydroxyl and the hydrogen atom. Then that's it. This molecule now is actually a beta galactose. So determine alpha or beta based on carbon 1. And by changing the arrangement of hydroxyl group and hydrogen atom, that one will be determined on the carbon number 4. So this is how you draw the glucose, the alpha glucose, beta glucose, alpha galactose, beta galactose. Fructose is easier because if you look back to the diagram just now, fructose have different shape. If you have a 6-carbon molecule, which is in the ring form, then definitely that is a fructose. Okay, definitely that is a fructose. But don't mix it up with the 5-carbon sugar, because 5-carbon sugar can also look very much similar with a fructose. But that one you can actually go through by yourself in the Campbell's biology. So where to find it, or how to use the Campbell biology to find all this molecule? So first, open up the Campbell's in your reader. Any kind of reader is also can. Then turn on the bookmark. Okay, turn on the bookmark. You're going to see a list of content. This is all the chapter that found inside the main reference. So we want to find carbohydrate. Carbohydrate is in chapter 4. So we click on the chapter 4, they will automatically jump into the page of the chapter 4. So now we can scroll down and find the information that we want. Okay, you notice that there will be a lot of information involved. So in order to find the information faster, normally we look at the diagram lah. So the diagram can help us to find or locating the information faster. So this is the information relating to the lipid. Next, we go through, okay, so this is the functional group. Okay, if don't have, then we go to the chapter 5. Okay, the structures and function for large biological molecule. So the second way to locate it, whether your your topics is actually found inside the chapter or not, you look at the key concept. Okay, you look at the key concept. So the key concept involve polymer built up by monomer, carbohydrate. Okay, so carbohydrate is present. So we go to the carbohydrate, page 68. So look at the page number. Now it's 66, so we go to the page number 68. It's supposed to reach the carbohydrate. And this is all the molecular structure that you can find in a 3-carbon sugar, in a 5-carbon pentose, and the 6-carbon sugar hexose, with the category of aldose or ketose. So this is actually covered by the lecturer. Your lecturer is supposed to discuss this with you already. And yeah, this is the way how the ring form of the glucose is formed. They also shows the ring form already. And the one that we're going to discuss under the tutorial will be this diagram. So this one will be delivered in the second video later on. So your first video, we will end here with the structures of glucose, how to draw the glucose. You're supposed to know how to draw the glucose already, and you're also supposed to know how to change a glucose molecule into a galactose molecule. And that's it for the video 1.